Okay, let's talk about what these lines are. These lines are called, these lines right here, they're called the absolute value. Yeah, those are absolute value bars, right? And they mean something, okay? So I want you to know what the absolute value means when you see the absolute value bars. The absolute value actually means the distance away from zero. So under here, okay, Miss Bennett's going to write a little bit smaller. All right, so that way we can get it in here. But under here, you're going to write absolute value, and you're going to write what it means. Okay, so there we go. Okay, so absolute value. Okay, so that's the bar, and it's the distance away from zero. Okay, so before we even start solving the equations, I'm going to give you an example. Well, I'll give you an example over here. So if I have an equation that's the absolute value of x equals 3, I'm saying what number has a distance away from 0 that's 3? That's 3 units away from 0. Well, what number is 3 units away from 0? 3. So I know the answer to this is x equals 3. But guess what? There's one other number that's 3 units away from 0. -3 is also 3 units away from 0. So if we look at the number line, guys, and I'll just plot that number line. You are on fire. I love it. Okay, so I'm going to put the number line down here. If I look at the number line and I have 0 in the middle, okay, over here is -3. That is 1, 2, 3 units away from 0. Over here is 3. 1, 2, 3. It is also 3 units away from 0. So notice I have two values that could be the answer to what x is. It could be -3 and it could be 3. And so for that reason, we are going to do these steps in order to solve for an absolute value. Your first step is to make sure the absolute value expression is isolated. Isolated means that it is by itself. Just like we want x by itself, we want to make sure the absolute value expression is by itself. The second thing we want to do is set the inside of the absolute value equal to both the positive and negative number from the other side of the equation. Okay, so we're going to take the inside, set it equal to the positive and negative number of the other side of the equation. The third thing that we're going to do is solve both equations. Okay, we'll solve them both. And the last thing we're going to do is write your answer as a solution set. Okay, this is a solution set. This is when we have more than one solution. I use brackets, okay, and I'm going to put my solution set in there. So in this case, our example that we did over here, we would have a x equals -3 and 3. That's our solution set. Are we all on the same page? Okay, so let's look at number 1. We're going to do exactly what they say. We know we can get two answers out of this because we're talking about distance, both on positive and negative side. So I'm going to make sure my absolute value is by itself. It is. We're good to go. And then I'm going to set whatever is inside, which in this case is x, equal to the positive and negative of whatever is outside, which in this case is 2. So I know the answer is x equals 2 and x equals -2, the positive and negative. All right, guys, go ahead and do number 2. with me. Tell me, what would M equal? All right, we go through the steps. Absolute value is by itself. It's isolated. Now we're going to set both sides. Hold on. Miss Bennett forgot her last step. I forgot to write number 1 as a solution set. X equals my brackets -2, 2. Sorry, I forgot that. There we go. Now, guys, I want you to do number 2. Do exactly what we said. Okay, it's isolated. I see some of you already put in the answers in the chat box, face-to-facers. What would this be? Alex, what would M equal? 14 and? Yeah, and -14. And I'm going to do my solution set. M equals my brackets, okay? And then I would have -14, 14. All right. Let's go to the next one. I'm going to put this on pause. Okay, so let's look. We go through each step. Step number 1 is to make sure the absolute value is isolated. Okay, it is isolated. It's by itself. Step number 2 is set what's inside to the absolute value equal to the positive and negative of the outside. So the inside of the absolute value is 5z. I need to set that equal to 40. And then I also need to set 5z equal to -40. Okay? Then what am I going to do? Well, it said to solve both of these equations. So let's solve the left equation first. If I solve the left equation, I'm dividing both sides by 5. I get a z equals 40 divided by 5, which is 8. One equation, I need to solve that equation, okay? Which means I divide both sides by 5. And I get a z equals -40 divided by 8, which is -8, okay? What is my solution set? Well, z, I keep writing x. Miss Bennett keeps writing x. But it is z equals, I do the weirdest brackets too, -8, 8. There's our solution set. All right, -8 and 8. So are we seeing how even if inside the absolute value is a little bit more complex, we're still doing the same thing. We just need to make sure we solve both equations, okay? Let's look at number 4. We're going to make sure the absolute value is by itself. We're good to go there. We're going to set what's inside equal to the positive of the other side of the equation, so +28, and then the negative, okay, -28. And then we solve both equations, which is step 2. So the first equation, the left side, I'm going to divide by -7 on both sides, and I end up with an a equals -4, okay? And the right side, I'm going to divide by -7 on both sides. And I end up with a equals +4. Okay? And I'm going to draw my solution set. A equals -4, 4. Not so bad. No, this isn't that bad. All right, let's go to the next one. Is the absolute value by itself? Yes, it is a low. So, Kamari, I go inside. I take d plus 1. I'm going to set it equal to 8. And then d plus 1 set equal to -8. So, I have d plus 1 equals 8. Then d plus 1 equals -8. All right. I am going to solve the left and right side. So for the left side, I'm going to subtract 1 on both sides. I end up with a d equals 7. On the right side, I am going to subtract 1 on both sides. Be careful now, guys. Be careful. Don't assume that it's always going to be the positive and negative of the number. It doesn't work like that. When I subtract 1 this time, I end up with a D equals negative 15. Does everybody see that? So don't just think, oh, it's going to be the positive and the negative. No, 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 no. It doesn't always work like that. It doesn't always work like that. Are we all on the same page? With that being said, guys, I do my solution set. I got a negative 15, 7. All right. Guys, on the next one, W minus 3 equals 4. I need to make sure the absolute value is by itself. Is it by itself? Yes, so I'm good to go, all right? So I'm going to say W minus 3 equals 4, and W minus 3 equals negative 4, the positive and the negative. I need to solve both equations. On the left side, I'm going to add 3 to both sides, okay? So I would end up with a W equals 7. On the right side, I'm going to solve that equation, and I'll be subtracting 3, or adding 3, to both sides. This time I end up with a W equals negative 1, okay? W equals negative 1. I'm going to do my solution set for W. W equals a negative 1, 7. How are we feeling, guys? How are we feeling about those absolute values? Yes.
For number 5, how for the D plus 1 equals negative 8, how is it 15? Wouldn't it be negative 9?
Yeah, what is Miss Bennett? You know what? I was looking at that because I was like, that doesn't seem right. Yeah, I don't know why, but Miss Bennett's mind is thinking this is 7. She can't read her own handwriting. You're so right, guys. That is not right. And I was like, that doesn't feel right. What is going on there? You are right. It is definitely negative 9 because that is a 1, not a 7. Miss Bennett, yeah, it's negative 9. That is right. Thank you. Okay, so this is negative 9. Negative 9, 7. Thank you. All right, guys, let's go to the next one. Let's go to the next solution set, okay? The next one says something interesting, and I'm going to pause this. Somebody help him out. Kamari, what is the first step with this? Not distribute. What do you, huh? Yeah, okay, so it's isolated. It's all by itself. So what do we do next?
Set up the equation.
How?
4 and plus 5. 2.
Equals what? And then what?
You do.
Before we do that, we also have to say 4n plus 2 equals what, guys? Negative 34. That's how we're going to handle it. We're going to do exactly what Kamari said. First, we're going to make sure that the absolute value is by itself. Once we know it's by itself, we'll go ahead and take what's inside of the absolute value out, set it equal to the positive and negative of the other side of the equation. So let's solve for the left side. I'm going to subtract 2 from both sides, okay, on the left. and I get 4n equals 32. And then I'm going to divide by 4 from both sides, and I would get n equals 8. Now I'm going to do the right side equation. I'm going to subtract 2 from both sides, and I get 4n equals negative 36. And then I'm going to divide by 4 from both sides, and I get n equals negative 9. Okay? Solution set. And this goes back. Tia, how would I put the solution set? Yeah, it's going to be, thank you, Uretzi. It's going to be negative 9, comma 8, right? So we want to make sure we do the least, we order our solutions from least to greatest. Let's look at number 8. Okay, let's look at number 8. I end up with I have first step, I'm going to look and make sure it's isolated. The absolute value is by itself. So I'm going to take what's inside, negative 2v minus 5. I'm going to set it equal to the positive of what's on the other side of the equation. So positive 17. All right. Then I'm going to do the same, and I need a little bit of space, so I'm going to move this over. So I'm going to do the same, negative 2v minus 5, but I'm going to set it to the negative of what's on that equation, negative 17. All right, negative 17. All right, now I am going to go to the left side, and I'm going to go through my steps. I'm going to add 5 to both sides of the equation, okay? So I end up with a negative 2v equals, and for this, let's see, what is it, 22? All right. And then I'm going to divide by negative 2. Divide by negative 2. And I end up with v equaling negative 11. All right. On the right side, I'm going to add 5 to both sides of the equation. Now I end up subtracting. Okay, now I end up subtracting. So I end up with a negative 2v equals negative 12. Okay, and let's move this over. And then I'm going to divide by negative 2 on both sides. And I end up with a v equals 6. So for my solution set, I am going to have v equals a negative 11, comma 6. All right. Now, pausing this with the absolute value, then that is not good. We need to go back to step 1. So go to step 1, which is to isolate the absolute value. Okay? Put that in your notes. Put that in your notes, okay? You need to isolate the absolute value. So if we look at number 9, notice number 9, the absolute value is not by itself. It has this plus 2 here. That is not a good look, guys. We got to get it out of there. Well, how do I move it to the other side? Anybody? How do you move that 2 to the other side to get it out? Anybody? E-learners or face-to-facers? How do you move the 2 to the other side? Would I distribute this in? It's being added to the absolute value. Yeah, that's not probably what we do. Is this division or is this multiplication here? Ah, no. We're going to subtract 2. Yeah, we just subtract 2 from both sides of the equation. And now I can write this as a absolute value of C. The 2's go away. It equals to 10. 12 minus 2 is 10. And now this looks just like what we were doing before, right? Where I set what's inside of the absolute value equal to the other side of the equation. So I would have a C equals 10 and a C equals negative 10. So my solution set, I don't have anything more to do. My solution set is negative 10 and 10. All right. Over here, number 10. Yeah, it's not so bad. Number 10, I'm going to do the same thing. I notice the absolute value is not by itself, so I got to isolate it, okay? I have to move that 8 to the other side of the equation by adding 8 on both sides, all right? When I add 8 on both sides, I end up with an absolute value of y equals 3. And now this looks exactly like what I am used to dealing with, right? I set y equal to 3, and then y equal to negative 3, right? Just pulling it out of the absolute value. My solution set then would be y equals negative 3 and 3. Okay? Now let's look at this situation. This time I'm multiplying something times the absolute value of x. What should I do to get rid of that something, that multiplication? Olivia, any idea? How could I get rid of this 6 to get the absolute value by itself?
Good morning, Signal Festival. Please stand for the pledge of allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under.
Thank you for dropping that in. Should we, if we're dividing, should we subtract? How do we, if we're multiplying, should we subtract? How do we undo multiplication, guys? Inverse operations. We'll use the same inverse operations. What's the opposite or the inverse of multiplication? Division, yeah. So to get this 6 away, because it's being multiplied by the absolute value, I'm going to divide both sides by 6. Does everybody see that? Yeah. So we'll end up with the absolute value of x equaling 24 divided by 6, which is 4. And then I'll go through my same steps, right? X equals the positive of 4, and x also equals negative 4. My solution set, x equals negative 4 and positive 4. How are we feeling about this stuff, guys? It's okay. All right, I want you to keep the notes, and we're going to finish this tomorrow. Have a wonderful day, guys.